of the oil, which the oil would float on top of the water, so we would know if there is any pollutant spread in certain places. Then we can use it to model the large-scale application, like the whole area, to see, okay, where would the water be, and if there is a lot of water coming here, there is a curve over here, will there be a sedimentation along this shoreline? Okay, we can help with that too. Okay, here are some other examples of the dam simulation, having the water on top after we design the reservoir place to see if this place is good enough. Do we have to do anything along this shoreline? Maybe can build something to prevent the water going up this area. Okay, and after that, we would know exactly how much water would be coming out to here, to your dam, and then this dam can be built in with the power generator so that you can build power from it. So here are the typical power plant component. So we have the dam over here, then we have the turbine and the generator on top of it. And we can help with the fluid simulation with the safety simulation. We can help you design this type of the turbine to see what type of turbine will have giving you the best efficiency and the outflow, what would outflow be? Do we need something to have a treatment over here? Will we disturb the environment around it or not? Okay. And here are some other examples of it. And after we have done with the fluid simulation, we can use the fluid simulation to couple with the structural analysis so that we would know if our structure that we are used for this dam, for this hydro generator would strong enough. So normally what's going on here is if you map the pressure acting from the liquid to the solid around it. So here, then we would know, okay, there is a water high pressure down here. Okay, do we have a thick enough of the dam? Do we need to change the material? Something like that. And for the turbine, this will give you some of the turbine. However, this one will be in the ocean. Let me give you a quick video from it. Okay, so the tide come in and we will push this turbine and it will give you with the generator on top. So here is our model for simulating this type of the hydro turbine. So we have the inlet where the water or the sea is coming in, and then we have the turbine, the impeller over here. There are 3 rows of it, and this blade, this impeller, it will be rotating around this point. So this rotor, after it coming here, it will be pushed down away, and it will come back to align with the flow of the water again. Okay, so they will give you a better picture of how we model it. So we have the center of rotation here, and then we will creating the movement by using the UDF to stating that the rotor, it will moving around here, and with the pressure pushing from the water. And as you can see, the model is quite complicated if we are going to mesh it with a single model. So in this case, we are using the technique called the overset mesh, meaning that all the components will be meshed separately, and then it will be imported all together, and it will have some type of the program function that it will blend this mesh all together. So as you can see in this picture, there are 3 rotors over here, 3 blades over here, and this around the circle is the mesh just for the impeller. And then if you blend in, as you can see along this line, the mesh will blend in together with the background of the water. This type of mesh is very easy to generate it and very easy to simulate it. And when the movement of this, meaning that the mesh will be independent of the mesh behind it. So if you mesh it as a one component and using just the regular dynamic mesh, it can pose a lot of issue when the mesh moving, having a lot of deformation or moving away from the original places. Okay, here is the result of the simulation. As you can see, the water push it in, and when it come down, we rotate back. So this will help with the generating the power while the blade would not obstruct the flow when it coming back to get the pressure again. Okay. And next, I will be talking about the wind turbine. Okay, so wind turbine is another application with today's renewable energy because the wind is free. However, putting the wind turbine requires a lot of analysis before we putting the wind turbine in. So such as, do we have enough wind in the certain area that we are going to build this turbine? And what type of the impeller are we going to use? How would we design it? And this thing can create a lot of noise too. And if there is any population around here, then we need to look whether the wind will create a noise pollution to those areas. Okay. And let me give you some example, the model that we have done. So in this case, we are using the 3 bed of the wind turbine. We have the wind turbine coming here, and we will simulate how would this go together with the strength of the hub over here too. For the fluid side, here are the mesh that we are using. In this case, we are using the polyhex core, which is one of the efficient mesh, apart from the using just the tetrahedral, and this one is very easy to simulate. And here is the result. As you can see, we can see all the wake behind the blade. And with this, it can help you whether the blade design that we have are good or not. And then we can redesign it. If it's not good, you can redesign if it creates too much noise, because when we are simulating the fluid flow, we can also be able to simulate the acoustic or the aeroacoustic that create from the turbulence also. And this noise is something that we add on into the Ansys fluent. So apart from the fluid flow, we can create the noise, and we can see whether the noise will travel too far or not. But in this case, we have like a kilometers over here, and then we have a safe zone to the 2.5 kilometers over here. So if there is any population nearby, we can plan ahead and not giving any noise pollution to those population. And from that, we can also see if the hub design or the impeller design in the structure are good or not. Since this type of turbine, it will be getting the stress all day long, so we can need to have some type of analysis first. This is some of the example flow that we can do. So we have the static structural that we get the pressure from the wind. So in this case, there are 2 ways that we can do. We can just use the pressure inside this program alone, or we can do the coupling with the Ansys fluent. So any flow, any pressure generating from the fluid will be sent directly into this program. This is the similar way on the previous one that I showed you that when simulating the dam, we simulate the fluid first to see where the water are and where the pressure would be, and then transfer all those pressure data into the static structural. Then after this, we create the loads on it, and then we can look at the model and later on at the vibration that it's creating. And after that, after we have done all that, then we use the SN curve to finding where the fatigue would be. Would it handle enough cycle of its lifetime? And how often do we have to replace it with a new one? And here is the result after the design. So after all, with the design, we give you the optimal thickness at the 0.149 to be the optimal one that it won't be too thick and too heavy or too material waste, while it won't be too thin that it will create a lot of fatigue and fail at certain point. Okay. Next will be the battery. Now, in today's, as we know, electric vehicles or any electric application, battery becomes a big part of it because it is the only place that we can store energy from the electric. However, there are a lot of challenge inside with the battery simulation. The battery simulation is a very complex one. Okay, let's look at this one first. Now, what happened is we would need to look at the molecular level of how the battery is designed, okay, of how its cells are designed, then at the electrode to see how the current are moving from the cathode to anode, all of that. And then we can look at the level. Let's say we have a type of the battery like cylindrical. How would the row be? Okay.